Hey everyone, today we're talking about how to connect to Private EC2 using Session Manager. And honestly, this might be one of those AWS features that makes you wonder why you didn't know about it sooner. We'll build this whole setup from scratch. I'll show you the architecture and walk through each component. Trust me, by the end of this video, you'll probably be rethinking how you approach EC2 access entirely. So here's the thing. Before Session Manager, we reached private EC2s the old way, through a Bastion host. Here's a VPC, the network boundary for our applications. In the public subnet, we place a single entry point. A security group allows limited inbound access. This is the Bastion host, the jump box everyone logs into. We expose an EC2 in the public subnet, open SSH to the world or to office IPs, and log in. Our applications run safely in private subnets. App instances have their own lockdown security group. Here's App Instance A and App Instance B. Engineers connect from their laptops or the office network. They first SSH to the Bastion over port 22. Then they hop from the Bastion to each private instance. The solution works, but now you're managing keys, users, patches, and hardening on that jump box. And it also increases attack surface and audit complexity. So what if I told you there's a better way? A way to reach your private instances without any of that overhead. No Bastion hosts, no SSH keys, no inbound ports at all. That's exactly what Session Manager gives you. Let's talk about the concepts first. Session Manager is part of AWS Systems Manager. It lets you manage EC2 from a browser or the AWS CLI. No inbound ports, no Bastion, no SSH keys. All traffic is encrypted in transit. Session Manager API activity, start session, terminate session, etc., is logged automatically in CloudTrail. If you also want the full command IO transcript, enable Session Manager to stream logs to CloudWatch logs or Amazon S3. Okay, so how does it actually work? Let me walk you through the flow. On the client side, we have a user and a terminal here. The user opens the terminal and types AWS SSM start session. The AWS CLI authenticates with the user's IAM credentials, then hands the request to the Session Manager plugin. The plugin takes the session information, prepares the secure channel, and gets ready to stream the user's keystrokes and output. Now let's talk about what's happening inside AWS. The Systems Manager service runs completely inside the AWS cloud. When you start a session locally, the Session Manager plugin sends an HTTPS start session request. Systems Manager checks your IAM permissions, creates a session ID, and returns the connection details like the stream URL and channel parameters so the secure session can begin. So AWS has approved the session and handed back the connection details. But how does that reach a private instance with no internet access or no inbound ports? This is where your VPC setup does the heavy lifting. You'll create 3 interface VPC endpoints in the same VPC and subnets as your private EC2s. The first one, SSM, is basically the front desk, the Systems Manager API. The second one, SSM Messages, is the live wire. It streams the interactive session data, your commands, and the output. The third, EC2 Messages, handles the control and status messages that keeps the agent and service in sync. Together, they form the private path in and out without ever opening an inbound port. In short, traffic stays on AWS's private network. Now let's look at the EC2 side. The SSM agent running on your instance maintains outbound connections to all 3 endpoints. Let's start with the SSM endpoint. This is where the agent registers itself, sends heartbeat updates every 5 minutes through update instance information, and handles core API operations like checking for associations and managing instance state. Next up is SSM Messages. the primary workhorse. This is where Session Manager creates control and data channels, streams your interactive session, and delivers run command documents through the Amazon Message Gateway service. Commands flow in, output streams back, all in real time. Finally, there's EC2 Messages, the legacy fallback, using Amazon Message Delivery Service. When it's active, this endpoint handles operations like acknowledge message, get messages, reply, delete message, basically the agent pulling tasks and sending responses back. But it's only used if SSM messages permissions aren't available, and it's not even supported in AWS regions launched after 2024, mostly here for backwards compatibility. And right here is the local OS and shell, Bash or PowerShell, where commands run. Inside the instance, the Amazon SSM Agent runs as a service. It spawns the shell, executes commands, captures output, and sends everything out over TLS WSS. Now, to make this connection work, you need to set up the security groups correctly. It's actually pretty simple, but you need to get both sides right. First, let's look at the EC2 security group. Here's the outbound rule. You need to allow HTTPS traffic on port 443 going to the VPC Endpoints Security Group. That's it. The instance initiates the connection, so outbound 443 is all you need. Now flip to the VPC Endpoint Security Group. This one needs an inbound rule. Allow HTTPS on port 443 from the EC2 Security Group, so the endpoint accepts those connections the instance is making. Notice what's missing here. No inbound rules on the EC2 instance. No SSH port 22, nothing. The traffic flow is entirely outbound from the instance to the endpoints. That's the beauty of this setup. Your instances, they completely lock down, but you get full shell access through AWS's private network. So the network path is open, but there's one more critical piece: authorization. Your EC2 instance still needs permission to actually talk to Systems Manager, and that's where IAM comes in. You'll attach an IAM role to your instance with the Amazon SSM Managed Instance Core policy. This is AWS's managed policy that gives the SSM agent everything it needs: permissions to register the instance, send heartbeats, pull commands, stream session data, all of it. Without this role, the agent can't authenticate to Systems Manager. The endpoints are there, the network path is open, but IAM validates these permissions first. If the role isn't attached or doesn't have the right policies, the service won't let the agent in. So this role is non-negotiable. It's what proves to AWS that this instance is allowed to be managed by Systems Manager. And here's the nice part. It's a managed policy, so AWS keeps it updated as new features roll out. You don't have to craft custom permissions or worry about missing something critical. Attach the role, and you're good to go. Now here's something you get for free: full audit logging through CloudTrail. Every session activity gets logged automatically. Start session, terminate session, who did it, what instance, when it happened. CloudTrail captures it all. No parsing SSH logs, no reconstructing access from multiple sources, just a complete tamper-proof record tied directly to IAM identities. And because it's at the API level, there's no way around it. Every Systems Manager call goes through CloudTrail. Compliance teams love this. Centralized, immutable, and you can set up CloudWatch alarms for unusual access patterns. So there you have it, Session Manager in action. 3 VPC endpoints, 1 IAM role, a couple security group rules, and you've completely eliminated the need for Bastion hosts. Your EC2 instances stay in private subnets with 0 inbound access, but you get full shell access through AWS's private network. Everything's encrypted, everything's logged, and honestly, it's just cleaner. If you're still managing Bastion hosts, I'd seriously give this a try. Start with a test environment, follow the steps we covered, and see how it feels. Once you've got it working, you might find yourself retiring those Bastion hosts for good. All right, that's it for today. If you found this helpful, Drop a like, subscribe for more AWS deep dives, and let me know in the comments what you want to see next. Thanks for watching, and I'll catch you in the next one.